Kinetics is a study of reaction rates, or the speed at which the reactants change into products. The rate of a reaction can be measured in one of two ways. You can either measure the decrease in concentration of a reactant over time, or you can measure the increase in concentration of a product over time. So the rate is the change in concentration of either your reactant or your product over time. Reaction rates are not constant, they change during a reaction. So on the right, we have a graph of the concentration of both reactants and products over time. If you graph the concentration of the reactants, you can see how quickly they're getting used up during a reaction, so their concentration decreases over time. And if you graph the concentration of the products, you can see how quickly they're being formed during a reaction, so their concentration increases over time. And you can calculate the rate of a reaction by calculating the slope of your curve. So on the left, we have examples of two different slopes of products being formed. One has a much steeper slope compared to the other. A steeper slope indicates a faster reaction rate, and this more gradual slope indicates a slower reaction rate. In the example below, we have a graph of a reactant being used up in purple and a product being formed in green. The first question asks for the rate of the reactant between 10 and 20 seconds of the reaction. So we're going to calculate the slope of the reactant during that time. Slope is rise over run, or in this case, the change in concentration or amount of a reactant over the change in time. The second question asks for the rate of the product between 10 and 20 seconds. So now we'll calculate the slope of the product during that same time. Notice how the rate of the reactant being used up is the same as the rate of the product being formed. Now that's not always the case, but it makes sense here because the slopes look similar in the graph. The difference is the rate of the reactant is negative because it's being used up during the reaction, and the rate of the product is positive because it's being formed during the reaction. The last question asks what happened to the system at 60 seconds. So at 60 seconds, both curves level out, which means the rate of the reactants getting used up and the rate of the products being formed are the same. This is the point at which the reaction is done. The reactants are still being used up and the products are still being formed. It's just that those things are happening at the same rate, so we would say the system is now at equilibrium. The next example on the following page gives us the reaction 2A plus B yields 3C plus 2D. What is the rate of the reaction if the concentration of A changes from 0.5 to 0.2 in 40 seconds? Again, calculate the rate using the change in concentration or amount over the change in time. The second question asks for the ratio of A being used up to C being formed. According to the balanced equation, 2 moles of A produces 3 moles of C, so it's a 2 to 3 ratio of A to C. What is the rate of the reaction in terms of C? So if we know the rate of A being used up, and we know the ratio of A to C, we can convert from A to C using the mole ratio. Now remember to pay attention to the signs of your reactants and products. A has a negative reaction rate because it's a reactant and it's being used up during the reaction. But C should have a positive reaction rate because it's a product and it's being formed during the reaction.